Okay, so today we will be looking at advanced encryption algorithm. This algorithm is used in ciphertext and plain text conversion. So advanced encryption algorithms has the following flow diagram, right? So the first plain text will come, which is going to be of 128 bytes, alright. So this 128 byte plain text is given to the round key, and inside of it there is also our secret key or the key that we are going to use to encrypt the algorithm. So we will be having that key which has a follow. We'll be looking forward into it a bit later, but which is like 128 bit key and 128 bit of plain text is going to come. The first step is going to be add round key, and inside of that add round key, we'll be performing a few steps. So, and then there will be round 1 to round 10. This is the same rounds that are going to be performed over and over again. This is going to be like this: that first substitution bytes, the second one is shift rows, the mix columns, and add round key. Then we are going to perform multiple times. Next, what we are going to do is that going to look at each of the rounds and each of the steps inside that round in detail. Okay, so let us start with the four words. What is the four word that we are talking about? How to solve, like we have a secret key which is of 128 bits. Okay, so the calculation here goes something like that. 128 bits of secret key. Okay, let me change the color. This is like 128-bit secret key. Now that 128-bit secret key is going to be expanded into from 0 to the word 0 to 3 is going to be used for the add round key method that we'll be looking at inside of in a moment. But that 128-bit secret key is going to be expanded to 44 bits, like for the 44 columns numbers. All right. So from 0 to 3 is going to be used inside of our add round key, and then from 4th still enough from 44th, from 4th till 44th we are going to be using it for each round, and we'll be looking into the details of how we are going to do that. As we can see over here that we have a word which is 0, 1, 2, 3. This is a single word. Each of this is a word. Now what we are having in a word is consisting of four keys. A word consists of four keys and each key is 8 bits. So each key K0 is of 8 bits. This K1 is also of 8 bits, and then the word itself is consisting of these four keys. Okay, this four keys is the word consisting of, and we have from word 0 to word 43. Word 43. Now the first process in the encryption process is substitution sub bytes. So how is sub bytes going to be performed and how it is actually performed inside of our encryption algorithm? So inside the sub byte, each cell is represented by one byte. Okay, so we have this cell. All right, we have this cell. So it is that we have this particular cell. This cell is going to give me information. Let's say it give me information 0 1 0 1 0 1 double 0. Now I will divide that into the row first four bits, and then the last four bits are going to be taken in as a column. So what happens is that the row will give the first four bits of this 8-bit output of from S00 is taken, and then the output is considered for the first four bits. The value which is given from the first four bit is considered for the row, and the last four bits is considered for the columns. So in the next process, what we're going to do, that is the 8-bit value that we have, as the first four bit tells us about the rows and the last four bit tells us about the columns. Now we will going to look at the AES table. The AES table that we have, we will be looking into it and then finding what is the answer of that particular cell. So in that particular case, we have 5 comma 4. That is the 5 comma 4 is the particular cell. That fifth row and fourth column is the cell that we want to look for. And for example, if we get for the fifth row and fourth column, we get 20 as the output. Then we will convert the 20 into an 8-bit number, 8-bit binary number, and then we will put that onto the cell S00, S-00. The next step is shift rows. In shift rows, we are particularly shifting the rows in a manner that we have S00, S11, S22, S33 as the first row, as the first column of every particular, as the first row of every particular column, and we are going to transform the other bits accordingly such that we have as 00, the first row is going to be same as it is, but the second row, and the second row we will have as 11 as the first column, 1 2 1 3 and 1 0. So the S33 will be shifted three times. So this whole operation is for shifting the rows as we are seeing. Now we will go to the mix column operation. Inside the mix, inside the next operation, which is of mix column. In the mix column operation, we are given two inputs. One is the predefined constant input that that we got when the starting of the video, and the other one is the input data. Now we have to see that this is 4 cross 4, and the input predefined input of a matrix 4 cross 4 is also like is going to produce a 4 cross 1 output. And what are we going to multiply? We are going to multiply the first column and with the predefined output that we have gotten, and we will be generating a 4 cross 1 result. That is performed for each column of the input data. Now we will be going on to the add round key. This is the last and the easiest step. Inside this add round key step, we'll have this matrix of 4 cross 4, which is the output from the last operation. That is XORed with the keys that we have, right? We have 44 words inside of our table, which we have generated from the secret key that we had. Then with the expansion step bytes, where we have generated this 44 number of words. We will XOR it accordingly. We will XOR column wise, perform XOR on the columns. Each column will be XORed with the key, the corresponding key. The wi plus 1, I plus 2, and I plus 3 is accordingly placed as we will be using 0 to 3 in the first round. And now from, let's say if it's the fourth, fifth, sixth, and seventh word, which is being XORed with the column is S00, S10, S20, and S30, and then output is finally generated, and then columns or operation will be performed. This is the end of our encryption key. This is performed for 10 number of times, and then the final output will be the cipher plain text, which is of 128 bits.